Like Richard said, I'm Terence. I'm Hono2 on Twitter. I wear this blue hat. I have a bunch of titles. So the first one, I'm leader of the League of Blue Hats, so I wear blue hats. This is Jessica Suttles. She has a picture wearing a blue hat. This is Chris Kelly from New Relic. He photoshopped a hat on himself because it's a pretty cool league. I come from Austin, Texas, and there I'm known as the Chief Taco Officer. I believe tacos are the best thing in Austin. So if you're like from LA and you think tacos are amazing in LA, you really need to come to Austin. If you're in Austin, I will personally take you out if I'm in town to get some tacos because I think they're pretty awesome. I work on Bundler, like Richard said, as well as work for this small company called Heroku. We optimize for developer happiness. That's one of the goals of our platform. And I'm sure you've seen the git push Heroku master. So to deploy, you just type git push Heroku master, and it deploys your app to the platform. And I think about right now we're running somewhere a little over 3 million apps at this point. I am part of the Ruby task force, which is the Ruby product team to deliver the best Ruby experience we can on our platform. So we're centered around maintaining the build pack, working on community open source projects like Bundler, Rails, and other things, as well as helping out in the community. So if you have problems with that, please come talk to us. We'd be more than happy to listen to your problems. Come talk to us at our booth. We'll be there today and tomorrow. And then we also have Ruby task force meetings. I also work with this really cool guy, this coworker of mine, created Ruby. So really happy about that. But enough intro stuff. So today I'm going to talk about performance. So let's forget about scaling for a little bit. And any app that is well architected can be scaled much easier. So if we think about some of this stuff up front, we can concentrate more on scaling later on because our app will be set up in place to do that. So in this talk, we'll focus on sort of the performance of a single app on a single process initially. And the side effect of this, like I was saying earlier, is it makes the app initially easier to scale. So we can sort of push some of the other hard scaling problems with state and things further down the line. One of the first things I want to talk about is sort of speed versus throughput when we're talking about performance. So when I'm talking about speed, I'm talking about response times, like the how fast you're returning a page for a single response. And then when we're talking about throughput, we're talking about sort of the rates of performance here, like the bytes per second, often when you're talking about networks, and then specifically with web servers, you're talking about requests per minute that you can process on your web server. So obviously both things are important, and they're not like things that are independent of each other. They're definitely related. So obviously the faster that you can return a response, the more throughput you're going to get. Pretty simple. Like if your website does stuff in 200 milliseconds in a single minute, you're going to get more if you can cut that down to 100 milliseconds. And then there's sort of two parts to think about. There's like the client side and the server side. So when we're looking at the cycle of a single page, when you do request to server, you have the request and response, and then you have sort of the client side processing after the server returns a request that the customer sees when they're looking at a web page. So first we're going to focus on the server side part of it. So don't let your web server slow you down. So initially we recommended we didn't really put a lot of recommendations in our web server, and that's changed recently. So here we're talking about two different types of Ruby web servers that you sort of have a choice from. So the first one is a single request server. And what I mean by this is when you have the server and you get a request, it can only respond to a single request at a time, no matter how many requests come at it. So we have this legend here. You have this sort of monitor, like silo thing representing your web server, and then we're going to represent each of the requests with this upward-facing arrow. So obviously, we're going to have this web server sitting here, and then you get a request, and then it processes that request. And while it's still processing, you get another request. And you start like queuing requests. Like you're waiting for this first request to finish, and you get another request, and then you get another request. And then when it finishes this first request, you can finally return a response. And then after that is done, it actually starts processing the next request. And so in this talk, that's what we mean by single request server. So examples of single request servers are, by default, thin and WebRick. And for simplicity's sake, we're not going to talk about like threaded WebRick or threaded thin mode. I haven't used either successfully in production, so just going to avoid that whole conversation there. And on the flip side, we have concurrent request servers here. So the difference, obviously, is that you can process multiple requests at a time. So again, the legend for a reminder in case you forgot. So here we have a concurrent web server. We get a request, and then it processes that single request. And then when we get another request, it can process that request concurrently, and you get the request, and it processes it. And then when one of them finishes, it actually returns that response and continues to process the other requests, and then you only have the remaining requests left to process. So when we use a concurrent web server, we can achieve more throughput because we're processing more than one request at a time. And that means people are waiting less time for their for the request to be processed by the web server, obviously. So less waiting time means faster response times. And when we're talking about concurrency in Ruby, there's obviously two types of concurrency. You have threading and then like process concurrency here. And then when we talk about threading inside of a web server, we mean one process and multiple threads here. So if we think about the mental model for this, we have a single Ruby process, and it spins up a thread for each request. So in the example here, or in the picture up here, we have like maybe a thread pool of like 6. So you have 6 worker threads. And when it gets a single request, it sends it off to a single thread, and then that returns a response. And then if we send additional requests, it will go to, it'll check a thread out of the thread pool to get a response back from that. So the benefits of having a low memory, or the benefits of having a thread web server is that since you're doing it in a single process, all the threads share memory, which means you have a much lower memory footprint. So like a bunch of the Rails stack doesn't have to be duplicated. You can share that stuff in memory. And then obviously the downside is within MRI, you have the global VM lock. So you can only process one request at a time. But luckily, for a lot of web servers, a lot of this is done. You're spending a lot of time waiting on I/O, whether it's like through network calls or database calls, so you can actually process multiple requests at a time because I/O will put that thread to sleep, and it'll just start running a different thread. You can use stuff like JRuby and Rubinius to sort of circumvent the global VM lock because they don't have that in place, especially if you're doing, this is useful for stuff if you're doing a lot of like CPU intensive work. This is obviously super helpful. But probably the biggest downside here is that your code needs to be thread safe. And this is definitely not really trivial for a lot of Rails apps that are out there in the wild today. So you might be writing perfectly thread safe code, but you have to make sure that the gems that you're using in that request are thread safe, and there's a good chance that they aren't. I mean, even the Ruby data structures themselves aren't thread safe, so like operations on arrays and hashes are not thread safe. So like you have to make sure to wrap them in mutexes, or if you're using something like JRuby, you can probably use like Java util concurrent here. So even if when Rails 4 comes out and that is thread safe, there's still a lot of considerations to take into place when you're running a thread web server. So obviously the most popular multi-thread web server is Puma, and we've had some success using it in for some of our customers, they've been using it in production. I know myself, I've run into some threading issues with it personally, so it's hard for me to make a firm recommendation on it, but I know people in the wild have used it pretty successfully. And then the alternative is running multiple processes where each of the requests are generally using a single thread here. You're not using multiple threads to achieve request concurrency in that process. So in this case, you have a master process, and then you essentially spin up a bunch of worker child processes. So this would be like either through forking, or like maybe you have like a Mongo cluster or something, and then you have a master Mongo processing in the front, like back in the day when you would do this, and they would forward it to each of the Mongo process there. And so similar to the thread example, you get a request, and then it sort of sends that request to child, and then that like other process will return the response back. And then in this case, you can have a concurrency of 6. So the huge benefit of this is that we don't have to think about thread safety at all. So you can keep your existing Rails app and get concurrency out of it without having to worry, are my gems thread safe? I'm running thread safe code. Do I need to write a mutex here? And you can just sort of throw that on this and get concurrency out of the box. And then on MRI, since we're doing processes here, we get true parallelization, so we don't have to worry about like the global VM lock stopping us from trying to run 2 requests at a time. But the downside is that since we're forking independent processes here, they're going to consume a lot more memory. And there's been talks about copy on write, how you can save some memory there. But we found that in production, you don't really get this until you start using like Ruby 2.1. There's been significant savings there. Even in Ruby 2.0, we found that it consumes more memory than using Ruby 1.9.3 when using Unicorn. And then the multi-process server that most people are using here is Unicorn, which it has a master process and then forks off these child process to service requests. And at Heroku, we recommend for most Rails apps to use Unicorn. You don't have to think about any of the thread safety issues, and you can get some pretty good concurrency out of the box. And we don't do it just because it sounds awesome to have unicorns running on dynos. So to sort of give you an idea of like some examples of how much concurrency you can get out of a single dyno on our platform using Unicorn. So if you haven't heard of Code Triage, it's this app that essentially assigns, you can sign up for your favorite open source projects, and it essentially gives you an issue day and helps keep the bugs away. And so in this particular app, it's a Rails 3.2 app, nothing too complicated. We can cram like 7 Unicorn workers on a single dyno. So this means we're processing 7 parallel requests at a time off of a single dyno. And another example is on Bundler API, which is if you ever run bundle install and you get the like fetching metadata, it hits this server. Which runs on Heroku, and it's a small Sinatra app, and since the memory footprint is significantly smaller, we can get 16 Unicorn workers on a double dyno, and so that means we're processing 16 parallel requests for each dyno that we have up and running. And like I was saying before, the huge benefit here is that you don't have to think about any of these thread safety issues, and sort of the optimizations we're thinking about are independent of like whether we're sharing memory. We can do memoization in place, and you really only have to concentrate on a single process here. So given these examples, like now that I have my own app, like how do I know how many workers that I can run in my own app? It's probably what most of you are wondering as you like launch Unicorn stuff on the platform. And to quickly go over, like obviously, like the more Unicorn workers are running, the more throughput we're going to be getting. But like with each Unicorn worker we spin up, it's going to consume more memory. And then if you haven't seen the Unicorn config before, inside of the Unicorn RB file, you just set this worker processes line, and you can put any number, and that's the number of child processes it will spin up. So traditionally, in our single dynos, you have about half a gig of memory. And then recently, we launched 2x dynos, which gives you a gig of memory, which should give you a lot more headroom to spin up unicorn processes. So my first tip is you should enable log runtime metrics. And what this is it's a labs feature that we have at Heroku that in the logs, it will spit out memory and CPU usage information for each individual dyno of the runtime it's on. And then if you go to log2viz.herokuapp.com, you'll get a dashboard that sort of gives you real-time metrics. So you can see like the throughput here, like what the requests per minute are, like the amount of memory, the response time, and sort of like this general web dyno activity for the amount of workers you're using here. It doesn't log any of this information, so you can't like retroactively look back and see what you're using. But most importantly for this talk, you get to see the maximum number of memory you're using for the dynos. And obviously, we want to maximize the number of unicorn workers, but you want to keep the amount of RAM usage under the total amount of RAM that is available to you, or else you'll start swapping and you'll get some pretty terrible performance when you hit that point. And one thing that's important to note is to do these tests under load. So use something like Blitz.io or some of the other services out there, or even something as simple as Apache Bench, and just sort of like hit the various endpoints that you have, like sort of run it through its paces so you can see the maximum memory usage that you're using as you're playing with the various number of processes you're trying to run. Because you want to make sure under load and while like it's actively responding to requests that you're keeping it under the limit of memory. So in summary, for best performance, you want to choose concurrent web server so you can get a lot more throughput through your application. So let's now talk about sort of backend speed here. So one things, most of you guys probably have a database attached to your Rails app, and you want to look at like how we can look for queries that are slow, looking to add like indexes to some slow queries and optimize performance there. If you don't know about this already, inside of Rails itself, you can set this auto-explain threshold in seconds, which tells you, which you can set the number of seconds that a query can take, and then it will spit out in your logs the auto-explain of that query out, so you can sort of analyze and see like slow queries that are happening in your Rails application in production. And another thing you can do is if you're on Heroku, you're probably using the Postgres service that's run by our Department of Data team, which is a great service. And any of the new Postgres databases you're going to spin up are going to be on Postgres 9.2. And a lot of you probably don't know there's this pgstat statements extension, which creates this table that actually stores a lot of interesting information about your database and the queries you're running. So if you, on Heroku, you can open up a pSQL statement and then enable this extension. So you need to make sure to create this extension because we don't do it automatically for you. And this will start it logging all this information in that pgstats table. And once that's going, you'll have a bunch of queries that are happening, like the app's running in production or staging, and it's collecting all this information. And so then you can run this SQL statement to return you want to see the queries that are in here that are the slowest queries by the time it's taken, and you want to see, say, like the top 10. One thing to note is it keeps track of, it stores these queries until like, I guess, a data stat reset. So over time, it's gonna, as you optimize your queries, the total time is still gonna be, the slow queries are still gonna be in this result set. But this is just a sample of sort of trying to see what you can do here. And so you get this table information back. And what Postgres does, it actually normalizes the queries. So as you can see, it replaces like the parameters with question marks, and then you can see for each of these queries like how much total time is being taken, what the average time is, and from there you can sort of get a sense of like what your slow queries are. And with that, you can run explain analyze and see if you have any queries that are doing table scans and whatnot, and then add indexes to those queries that you're running to increase the performance on your database side. And another important thing to do is to make sure you're doing performance monitoring here. You want to be able to see visibility into your app. One of the great engineers I work with, Ryan Smith, has this quote that he shared with us internally: "No such thing as performance problems, only visibility problems." So if you can't really see why your app is running slow, like, you're going to have a really hard time trying to make it run fast at all. So probably the service that most of you guys are familiar with that does stuff to help you here is New Relic. And on our platform, if you have a Heroku app, you can add New Relic, and you'll get the standard plan for free. And New Relic does a bunch of great stuff with traces and other things to sort of give you introspection into your app. And it sort of gives you a general sense of like how your app is performing. Another tool that we use a lot internally is Librato. And this is sort of a great tool for collecting data and sort of showing graphs here. And one of the things that you have to do with Librato is you sort of have to instrument your app yourself, which we do a lot internally. There's a great gem for your app called Metrics, MERTIKS. And what that does, it does both the collection and reporting, and it has stuff built in for Librato where you can pass in your Librato account information, and you can get things like the 95th percentile, the max, the mean, and sort of get a slew of different graphs. And this up here is a sample dashboard of the Librato graphs that we have for Bundler API. So we can, I sort of just keep this page open on a separate monitor and see like what the overall performance looks like, and you sort of get a sense of what that is, and when that looks weird, like, you know, to kind of just start digging into your app, and you can get a sense of where to start looking. I think one of the great things about this stuff is you can get the 95th percentile here, because averages that you get and stuff like New Relic don't really tell you the whole story, and you want to be able to sort of see, like, you want to be able to have consistent performance here. So as your users use your application, if you have some really fast response times and some really slow response times, it's kind of weird. Like, users get used to sort of the cadence of your application of how fast your response times here are. So you want to definitely optimize for the slowest use case. And if you guys haven't seen any of the stuff that the Tilda guys are doing, they've been working on this Skylight product. And one of the things that's really exciting for me about this is it's one of the first apps where you really get like the histogram of the response times here. So you can see the distribution of your responses and where they sit. So you can see like the stuff here on the left, which is the fastest stuff. But probably the most interesting things are the sort of the bell curve and then the things on the slow end. And you're trying to look into why your app is really performing so slow on the opposite end of the spectrum. Or maybe like for caching, seeing like what the performance is when you cache an app for an endpoint and when you're not. And then, so it's really great to be able to do that. And we've been working with them to hopefully launch an add-on sometime soon. So really looking forward to being able to give this to customers. And of course, there's a bunch of other add-ons, or not add-ons, but services out there to help you sort of measure and do stuff like Scout and other things. So definitely make sure to metric and instrument your app, and it's a key part of, it should be as much as tests, like a big part of launching any new feature in your product. And of course, there's the idea of trying to improve the request time here. So you want to split up your web and worker processes here. And so when we talk about web processes, we mean all the stuff that's running, that's responding and doing requests. So the Ruby code there that in the controller that does the request processing and the stuff that goes to the models, and then obviously rendering the view. And then the workers, we mean everything that is handled outside of the web process. So if you need, so obviously the simple case that most people talk about here is like if you're sending out a registration email, you want to use a worker to actually do the email sending and then queue that up inside the web process. If you're making a slow query to an API, if it's possible, you want to use a worker because you don't want the users to wait for that API call to come back, unless it has to be synchronous. And then obviously any intensive CPU database or any type of calculation, you want to move that to a worker if possible. Doing slow web requests means slower response times, which means less throughput and lower performance. So the next thing is like now that you've like optimized your app, you've tuned your database, you've removed all your slow queries, you're using current web server. Now that I've run out of capacity for a single dyno, like what do you do? So you can either scale up, and this is like vertical scaling, and so you take a single machine, like you buy some hardware, and then you just like buy a bigger machine to handle it. You can spin up more workers, you can process things faster, you have more CPU, you have more memory. And then the other alternative is to scale out, so to scale horizontally. So given the same machine, you just buy a bunch of them and you scale them out. And it's less expensive because obviously with vertical scaling, you hit a physical limit of like how big of a machine you can get. So scaling up is really easy. You don't have to really change your code at all. You don't have to worry about communication between different processes. You just sort of buy a big machine and throw your code on it. The only thing you really have to worry about is sort of downtime migrating your app over. Scaling out is harder, but you can sort of theoretically have an unlimited amount of scale because you can keep buying more machines and make them talk to each other. And on Heroku, we have this concept of ephemeral web machines. So web machines that can go away, that you don't have to worry about the state of them. And so on the platform, a lot of you who've used the platform before know you can just run Heroku PS scale and sort of pass in the number of processes that you want to run. So this will set the number of web processes to 4. And that will allow you to scale out. And then for scaling up, the only thing we've introduced so far is to be able to sort of get double dynos, so the 2x dynos to increase the amount of RAM you're using there. So some mix between the two is probably a solution that you'll be looking at. And so now that you have sort of like the web runtimes running and scaling, like how do you scale out your database? So for a lot of applications I've looked at while working at Heroku, they've been fairly read heavy. So on the platform, you can have this concept of, we have in DoD the followers. So you can create a follower of any Heroku database that you're running. And so this allows us to split writes to your master database and then read from your follower databases. And this decreases the load on your master database, so it allows you to essentially scale out your app more to be able to just have a lot more load split across your databases. And in order to provision a follower, it's really simple. You just add a new Heroku add-on. In Bundler API, we actually do very little writing. So we have Ronin, which is our smallest dedicated database, as our master database. And then for our workers, we actually spin up fairly large, or for our followers, we spin up fairly large databases because they're handling sort of the brunt of the load from every time you run bundle install. It's just doing reads from the database. So when you read from followers, you can actually you can scale this out and spin up as many followers as you need. And then you can use a gem like Octopus to sort of distribute the reads in your Rails app. One thing to note is that each Postgres database allows a maximum of 500 connections under a dedicated plan. So if you're using Unicorn, for instance, you need to dedicate at least one connection per worker so it can actually connect to the database and do requests and process things. And then if you're using something like Puma, you want to have at least one connection per thread so they can actually all run concurrently. If you have a smaller thread pool than number of threads, or a smaller connection pool than your thread pool, the threads will have to wait for connections to open up. So if you're actually running close to this 500 connection limit, come talk to us at our booth. There's some things that yes?
I have a question specific to that. Why, in your existing system, you require that there's like, that you append the connection pool size to the database URL, I believe, for each of the apps in order to have that set, like by default, it's not actually set to 500.
So the question was, why do you pen the connection pool stuff to the database URL?
Well, like, why is that required?
So currently, you can't, because of the way that we have it set up in the build pack, you can't set something to, I guess, like write to the database YAML file to do that. We're just reading from the database URL. There's stuff we're working on to make that easier. We'll talk. You can come talk to us at the booth after, and I can show you stuff for it. So given a fast server, a fast database, that's sort of like a lot of the backend stuff. Let's move on and talk about sort of the front end and the client side stuff here. So for the client side, you have sort of the processing of the stuff in the browser and the downloading of all the things you need to load the page. And one of the things is, unless you're just returning like JSON responses or some data-specific thing, you're gonna probably have a bunch of assets here. And then all Ruby web servers are kind of really slow at loading assets. Like they're not optimized to do this. So when you hit a Ruby web server, it's not really super performant on doing that kind of stuff. And so things you can do to help out here is you can decrease the size of the assets that you're returning. So if you're not doing this already, you should probably be minifying your assets. You can compress your assets by doing gzip. And in the asset pipeline, I believe you can just flip 2 bits to get it to minify and compress your assets here. And then another thing to note, like with delivering these assets, the speed of that it's being returned is the distance over how much time it takes. So let's say your web server is somewhere on the West Coast. If you have a customer on the East Coast, the response time is going to be much quicker than if the person lives in Africa, because it has to travel all the way to your server on the West Coast to get it all the way to Africa. So the distance that you're traveling matters a lot. So if we have a shorter distance, obviously it's going to be much faster. So if we have, say, servers in Canada, because it's like cold and we want to keep our servers colder, and then you can have users in South America and like around the world, it'd be pretty awesome if we could have servers in each of the continents that they're at. So it's going to cut down significantly on the traffic time that you're getting responses for. So if you aren't doing this already, you should think about getting a CDN for any production application. So CDN stands for Content Distribution Network. And so we might not have a server in each of the continents, but you could probably have a CDN that's fairly close to each of your users. And the CDN is going to return any of your static assets here. So you're going to have images, CSS, JavaScript, fonts, things like that that are static. Anything inside of your app assets folder, basically, in your Rails app. So examples of this would be Akamai, CloudFront, Cloudflare. We also have an add-on in beta that you can use called CDN Sumo, which will help you get up and running really quickly on this so you don't have to have a bunch of different accounts. And then even inside of Rails, it's not super hard to configure this stuff. So you just set the asset host on the action controller to the URL of your CDN, and Rails will automatically, for any asset in production, will federate it to that URL out there. And the way the CDNs that I'm talking about work are, when you get your first request, what it does, it goes to the URL you're talking about, and if the CDN doesn't have it, it will go all the way back to the web server. And then that web server will return it, and then the CDN will store that asset on its servers. And then for every single future request, instead of going back to the web server, it will just return the asset it has cached. So this means that you don't actually have to sync any of the files ahead of time. When you deploy, like when those assets get hit, you'll just get the assets back from the CDN. So something that you might want to do upon deployment is to maybe hit all your assets really quickly after you deploy, so you can sort of warm up the CDNs that you have to sort of deliver the content really quickly. And then to sort of set, like, now that you have all these assets on the CDN, like, how long do we keep these assets around? So you can do this by setting the expiration headers on the assets. So inside of your Rails app, you can just configure the cache control for your stack assets, and you just need to set it to public, and then we're just going to set it to the max age that we can here, because there's no reason that stack assets should change. But as you're developing your application, you might make changes to your JavaScript or CSS, and you will want to flush that cache. So inside of Rails, we conveniently, with the asset pipeline, have this concept of fingerprinting each asset. So inside of your Rails app, you just need to make sure that the assets digest is set to true. So we're creating these fingerprints. And what Rails does basically here is it takes a hash, or does the hash computation to create a fingerprint for each asset. And the algorithm it uses here is MD5, and it does an MD5 algorithm on each of the files. And so for like a headers.css file, we get this hash here that represents that file. And then each time the file changes, it generates a new fingerprint. So inside of the asset pipeline, inside your public assets folder, you'll see both the headers.css file and then this headers dash and then the hash that it generates. And so when Rails actually inserts these in the views, it actually just puts the file with the fingerprint. So when you actually change your assets and you do a new deploy, the client actually requests a new file, so you don't have to worry about it. So with 3 lines of code, we can configure our Rails app to use CDNs and have faster assets being served back. And while we're talking about latency, one of the things we just launched recently was the ability to spin up Heroku in the Europe region. So if you have a bunch of clients in Europe, you can just create a Heroku app and pass this region flag and pass EU, and it'll spin up Heroku apps in Europe. And so if you're doing this, you're wondering, like, how can I actually get an app from the US to Europe? And so one of the things in the latest Heroku toolbelt that we have is this thing called Heroku fork. And you literally just run Heroku fork, the existing app name, and then the region you want to fork it to. And what this does is it takes the last release that you did on that app, copies the code and all the things that are bundled into the slug into your new app, and then creates a new copy of each of the add-ons that you're using, as well as forks any of the Heroku databases that you're using. So you have a complete new copy of this app in your new region. And so this will allow you to quickly spin up and test things in the Europe region, or if you have stuff in Europe and you want to move it back to the US East, it allows you to do that. So in summary, if you architect your app properly, you can sort of push off dealing with some of the scaling issues with state much later on and get a lot more headroom to scale your app out. So one of the things you want to make sure you're using a concurrent web server, try to stay away from sticking with the default web brick that's in standard lib. You want to make sure that you're measuring everything so you have data to actually tune things. So check out New Relic, check out Librato, check out Skylight. Move long-running tasks outside of your web request. Get introspection into your database so you can add indexes or do things to improve queries there. You can use followers and other things to sort of scale your database out without having to increase the size of your database. Even just like having a single follower will, if it's like 50-50, have the load on your master database there. And then use a CDN to serve faster assets. And then if you have clients in Europe, you will want to have your app servers closer to them so the response times there are quicker. That's kind of all I had for this portion of the talk. But here at RailsConf, we have a performance bar in the expo hall. So if you have any actual application-specific questions, over the last month, we've been doing a lot of white glove service of tuning customers' application, helping with visibility, helping with migration, and a lot of those engineers who've been doing that with a bunch of our customers are actually here at RailsConf. So come by the booth, ask us questions, ask us to help tune your database, ask us how we're doing our own scaling, how we're actually getting visibility into our own apps. We'll be there both for the rest of today and then all day tomorrow at the Expo Hall. Tomorrow night, we partner with Jumpstart Labs, where we'll be running a workshop with them at 6:30 in room D136. You have to sign up for it. If you go by the booth, talk to one of our engineers, and we can get you on the list until the class fills up. We'll be, in the first half of the thing, we'll be running the workshop where we'll be hands-on doing performance tuning and other things, and then we'll have a contest with prizes and for the fastest consistent response time afterwards, after learning about a bunch of that stuff. On Thursday, Richard Schneeman, who's sitting here in the front row, second front row, will be giving a talk on dissecting Ruby with Ruby in 252, 253, which I believe is the rooms down there at 11:30. So on the last day, he'll be warming up, I guess, before Aaron. And then, yeah, that's kind of all I had. So are there any questions? Cool. Thanks, guys.